Now that we've outlined the characteristics of the industry type we're going to explore for the time being, which is perfect competition, we can now move on to modeling the demand facing a perfectly competitive firm. And we can also discuss how this firm maximizes profits. Now, given the characteristics in the last video of a perfectly competitive firm, the one characteristic that really stands out is that they produce perfect substitutes. They produce homogeneous products. And perfect substitutability across firms means that if one firm charges even a penny more for their product, they will sell none of it. Everyone will go to their competitor because, being rational agents, which we assume consumers are, they use all available resources most efficiently to achieve their desired end, meaning, and their income is a resource, and holding constant transportation costs, etc. If Farmer Bob charges a penny more per bushel of wheat than all the other farmers in the industry, he will sell no wheat. And because you have a bunch of firms now, one characteristic, many firms, that's obviously a subjective term, many, but we're talking potentially hundreds, if not thousands, of firms. And because the industry is large and all the firms are small relative to the industry size, the industry doesn't suffer if they don't buy any product from Farmer Bob. They just simply buy from everyone else. In other words, Farmer Bob's portion of the entire industry output level is so minuscule that the industry doesn't miss it at all. Okay, now perfect substitutability or homogeneous goods means perfectly elastic demand. Okay, so we have a firm, okay, and again, I'm putting dollar signs this time on the vertical axis, and it'll become clear why later. It's because we're going to also embed a cost model into this. And a firm in this industry faces a demand curve that's horizontal. Okay, if they sell their product for 1 penny more, they sell none of it. They have no incentive to sell their product for 1 penny less because they can get the going market price. Okay, and sell all the product they want at that going market price. So it's not like, they're all small relative to the industry. It doesn't pay for them to charge a penny less than everybody else is charging, okay? Because they can sell all the product they can produce at the going market price. Now, what does this mean? This means that the demand facing this firm must be equal to the equilibrium price level in the market, okay? Now, we don't want to confuse this demand curve with market demand, okay? Now, the market demand for wheat would satisfy the law of demand in the sense that it would be truly downward sloping. You could raise the price of wheat in general in the wheat industry. Quantity demanded will fall, but it won't go to zero. However, if Farmer Bob tries to charge a penny more for his particular bushel of wheat, his quantity demanded will indeed go to zero. Okay, so just keep this in mind. We're looking at firm level demand here, not market level demand for wheat, which would be downward sloping. Now, we will come back and join the market up with Farmer Bob's graph, but we will do that later. We won't do it now. So now that we have Farmer Bob's demand curve, if we remember, the demand curve is also the marginal benefit curve, okay? But more importantly, we have to, what does this demand curve facing Farmer Bob tell us? Or what does it do for us? Well, we've got the price level. If we choose a Q on this graph, okay, and Farmer Bob sells that level of Q, well, guess what? That's P times Q. That area there is Farmer Bob's revenue that he generates from selling Q units of a product at P star price level. Now again, where are we going with all this? Profit maximization. Okay. Farmer Bob wants to maximize their profits, and in doing so, he would choose an output level that does exactly that. And if we remember, our profit function is P times Q minus ATC times Q. Okay, and ATC times Q being total cost. That is total revenue. So what designing this demand function for at the firm level does for us is it gives us this first term right here. Okay. Now, in maximizing profits, okay, we have to remember that a firm thinks on the margin, okay, and whereby a profit function is total revenue minus total cost. If we marginalize that function, so to speak, we get marginal revenue minus marginal cost, and that would equal marginal profit. Okay, so let me repeat all this. Firm's objective is to maximize profits. This is their profit function. They maximize their profits. They make that decision on the margin. In other words, they choose a Q. Okay, let me just call this Q star PC. So perfectly competitive firm chooses their optimal output level such that this function is satisfied, but they do that on the margin, okay? And so we get this marginal profit function then, which equals marginal revenue minus marginal cost. How does that play into Farmer Bob's demand? Well, let's think about it. First, we have to define what marginal revenue is. And marginal revenue is simply the change in total revenue from the sale of one extra unit. Okay, that's what marginal revenue is. Okay, change in total revenue from the sale of one extra unit. Well, what is total revenue? It's simply P times Q, like I just showed you. Okay, now what is marginal revenue then? Well, since Farmer Bob faces a demand curve that is horizontal and that's equal to the price level, then the question is, okay, what is the total revenue from the sale of the first unit? Well, it's equal to the price level. It's equal to that distance there. Okay, what's the total revenue if he sells 2 units? Well, it would be the revenue generated from the first unit plus the revenue generated from the second unit, which again is equal to the price level. So how much did total revenue change? By the price level. If he sells a third unit, what's the total revenue generated from selling all 3 units? Well, it's the revenue generated from the first unit plus the revenue generated from the second unit plus the revenue generated from the third unit. And that amount of revenue generated from the third unit is equal to what? The price level of the product. How much did total revenue change? What is the marginal revenue of the third unit? It's equal to the price. Just like it was equal to the price for the second unit and equal to the price for the first unit. In other words, Farmer Bob faces a perfectly elastic demand curve that is equal to the market price for the product, which is also equal to the marginal revenue of that product. So we're getting closer to mapping out that function. Now, so let's just redraw this. Farmer Bob faces a demand curve that's equal to the price of the good. and that's equal to the marginal revenue of the good. Let's put in a marginal cost curve into this model. Okay, now we've completed our profit maximization choice of Q. Okay, and how have we done that? Let's think about this. If this firm sells 1 unit, it costs them this much to produce that unit. Okay, but they make this much from that unit. Okay, this amount here is marginal profit. If they sell a second unit, okay, it costs them this much to make that second unit, but they get this much from the sale of that second unit. In other words, they get the price from the sale of that second unit. What's left? Positive marginal profit. Now, marginal profit, like marginal revenue, marginal cost, is a very equivalent concept. Marginal profit is simply the change in total profit from the sale of 1 extra unit. Okay, so if marginal profit is positive, that means your total profit is increasing. Let me repeat that. If marginal profit is positive, okay, in other words, if price exceeds marginal cost at a particular output level, marginal profit is positive. That means you're adding to total profit. Okay, now let's assume that this firm sells, I don't know, 7 units. Okay, would that firm produce that 7th unit? Well, no. Why? Because it costs the firm this much to make that 7th unit, but they only get the price level for it. Remember, horizontal demand curve. So they're actually making negative marginal profit on this unit. In other words, total profits are falling if they make that 7th unit. So they won't make the 7th unit. Where on this graph will they be then absorbing all positive marginal profits? In other words, where will their operating profit be the largest? Exactly where marginal cost equals marginal revenue. That is their Q star PC. Okay, PC again standing for perfect competition. That is their profit maximizing output level. If they stop short of that, say if they stop at the 2nd unit, well, then they're leaving profit on the table because marginal profit is still positive. They can produce 1 more unit and absorb more marginal profit, increasing their total profits. If they produce past that, then they're subtracting from their total profits because marginal profit is negative. So the optimal profit maximizing output level is where marginal revenue equals marginal cost. Okay, now how do I know that's the case? Well, let's plug it back into here. So how do I know that's the case mathematically? Let's plug it back into here. If marginal revenue equals marginal cost, then what must be true about marginal profit? It must be equal to 0. So if you've got 0 equals marginal revenue minus marginal cost, obviously rearranging those terms, you get marginal cost equals marginal revenue. And that is the profit maximizing output condition of this firm. What we're going to find is that's the profit maximizing output condition of every firm regardless of industry type. Doesn't matter if they're in a monopoly or monopolistic competition or perfect competition. That is the profit maximizing condition of every firm. In other words, every firm will produce where marginal cost equals marginal revenue. And in the perfectly competitive case with the horizontal demand curve, that is right at that intersection there. That is the profit maximizing output level.